Welcome to Data Engineering with Subhadip. Today, we are going to dive deep into optimizing data warehouse performance. We will explore how partitioning and clustering can unleash blazing fast query speeds. Why is optimizing data warehouse performance crucial? Modern data warehouses handle massive data volumes, often billions of rows and petabytes of data, growing exponentially. This scale directly impacts business operations. Slow reports and dashboards can delay critical business decisions, and inefficient queries lead to significantly higher cloud costs, as you pay for the amount of data scanned and processed, not just stored. First, let's understand partitioning. Partitioning is a divide and conquer strategy, where a large table is broken down into smaller, more manageable units called partitions. This division is based on the values of specific columns. The main benefits are significant. It drastically improves query performance by allowing the query engine to scan only relevant partitions, thereby reducing the amount of data processed and saving costs. It also simplifies data management, for instance, by allowing you to easily drop old data and enhances parallel processing capabilities. Let's explore common partitioning strategies. First, we have time unit partitioning, ideal for time series data, where data is divided by date or timestamp, such as daily or monthly. BigQuery commonly uses this with partition by date. Next, range partitioning divides data based on a specified range of values in a column, like customer IDs or sales amounts. While Snowflake doesn't have explicit range partitioning, it achieves similar benefits through clustering. Finally, hash partitioning distributes data evenly across a fixed number of partitions using a hash function on a chosen column, useful for balancing workload, often seen combined with bucketing in various systems. Let's look at a practical example in BigQuery. To create a partition table, we use the create table statement with the partition by clause. Here, we partition the daily underscore transactions table by the date part of the transaction underscore timestamp column. BigQuery then automatically handles the creation and management of these daily partitions. When querying, the magic happens. By including a where clause that filters on the partition column, like filtering for the 26th of October 2023, BigQuery intelligently scans only the data within that specific partition. This dramatically reduces the amount of data processed, leading to faster queries and lower costs. Now, let's explore clustering. While partitioning divides a table, clustering takes it a step further by physically co-locating related data rows within those partitions or storage blocks. This is based on values in designated clustering columns. The primary benefits are a significant reduction in I/O operations because the system reads less data from disk, and a substantial speedup for queries involving filtering or aggregation on clustered columns. Clustering is often complementary to partitioning, offering a finer-grained optimization, and typically involves a form of multi-dimensional sorting. It's important to understand the key differences between partitioning and clustering. Partitioning divides a table into separate physical storage units, often based on a single column like a date. Its main goal is to reduce the amount of data scanned, primarily focusing on cost reduction and macro-level query pruning. It essentially creates distinct subtables. Clustering, on the other hand, sorts and co-locates data within these existing storage units or partitions. It can use multiple columns for sorting, aiming to reduce the amount of data read from individual blocks. Its primary focus is on performance improvement and micro-level I/O reduction, physically arranging the data for faster access. Let's see clustering in action with Snowflake. When creating a table, you use the cluster by clause, specifying one or more columns, in this case, order underscore date, and customer underscore ID. Snowflake then automatically and continuously reclusters the data in the background to maintain optimal organization. When you query this clustered table, for example, filtering by both order underscore date and customer underscore ID, Snowflake leverages this physical data organization to perform highly efficient micro-partition pruning. This means it only needs to read a minimal amount of data, drastically speeding up your query performance. To effectively use partitioning and clustering, follow these best practices. First, choose your columns wisely. Partition on frequently filtered date or timestamp columns for time-based data. Cluster on columns often used in where clauses and join conditions. Be mindful of cardinality, avoiding columns with extremely high or low distinct values for clustering. Prioritize columns that significantly narrow down query results. Second, continuously monitor and adjust your strategies. Regularly check query performance and associated costs. Data access patterns evolve, so be prepared to revisit and modify your partitioning and clustering setup. Always test with typical workloads before full implementation, and remember to balance performance gains against potential storage and maintenance costs. To summarize, partitioning divides large tables into smaller, manageable segments, primarily reducing the data scanned and thus query costs. Clustering then takes it a step further by physically co-locating related data within those segments, further minimizing input-output operations and boosting query speed. Both techniques are absolutely crucial for cost optimization and significant performance enhancement in modern data warehouses. Remember to implement these strategies based on your actual query patterns and to regularly monitor their effectiveness. Fortunately, platforms like BigQuery and Snowflake offer robust and often automated partitioning and clustering capabilities to help you achieve this. Thank you for watching. I hope this deep dive into partitioning and clustering has equipped you with valuable insights to optimize your data warehouses for superior performance and cost efficiency. Don't forget to like, share, and subscribe to Data Engineering with Subhadip for more data engineering insights and tutorials.